A committee of 3 is to be selected randomly from 6 students. How many possible combinations, there's a key word right there, can be selected, okay? So let's try it again. A committee of 3 is to be selected randomly from 6 students. How many possible combinations can be selected? Problem of the day. Let's work this one out and let's play with it. All right, we want to put down all those combinations. We could do this mathematically. Well, we're going to do it mathematically anyway. We're going to think it through. But we could do this using the combinations formula. At the end, I'll go back and allude to that, all right? But I want us to count out and see what the actual numbers and such are. What we're going to do, we're going to spread this thing out. We're going to call this A, B, C, D, E, and F out here, all right? And A, B, C, D, E, F, they're just going to represent 6 people, 6 students. That could be Audrey, could be Barbara, could be Clay, could be Dan, could be Ernie, E for Ernie. You know, get the idea. Those are just indicating our 6 students. So what we're going to do, we're going to pick a committee of 3. No matter which order we put them in. Once we get that committee of 3, we got it. So for example, if I pick A, B, C, it's done. You say, what do you mean it's done? We don't put CBA, we don't put BAC or any of the other possible combinations, which by the way, there's 6 of them that you can do those 3 letters mixed up in. We're going to settle with it right there, be done. Now, what we want to do is start matching up the A and the B first. We're going to just take this very methodically. So I took A, B, C, but you know what? We can do A, B, D. How about it? A, B, E. Keep it going. A, B, F. There's 4 of our methods, 4 of our, I don't want to say methods, 4 of our combinations there. Now, let's keep A around a little bit longer. Pick up A, C this time. Leave out B for a little bit. We'll get B back in the game in a little bit, but not right now. A, C, and D. We'll put them as a combination. Keep going with me. But A, C, E. And why not? A, C, F. Looking good. Up to 7 now. Keep it working with me. We have A. Let's go with A to D. We'll skip over. You know, we've got A and we've got D, E. We've also got A, D, F. So we're up to 1, 2, 3, 4, 5, 6, 7, 8, 9. Denise gave me the 10th one on this, so we're going to go with A, E, F. That's the one that we missed yesterday. Now, let's keep working with this. That's just with A involved. So there's 10 of them. And that's good news to me. That was what I was looking for yesterday. Let's put the B in here. We've got B, C, don't want an A. All right, remember what I said? We've already used A, B, C, so we're not going to put BCA in there. Let's put D along with it. That's a new combination. We haven't had that one. While we're at it, how about B, C, and E? We haven't had that one, nor B, C, and F. So we're up to 3 more. We've got 3 more going for us here. Let's keep it going with B and D. About B, D, E, B, D, F, and oh yes, B, E, F. Already, we're up to 16. It's crazy, 16 combinations. Now we're starting to dwindle. Notice I didn't have 10 of those because I would have some repeats. And I'm not looking for repeats here. All right, we want to keep it 1 combination, period. So let's go to our next layer. We'll start with C. How about it? C, D, E. Why not? And why not C, D, F? And you know what else is next? Look at these EFs hanging out on the end. Why not? C, E, F. We are up to 3. Plus 6, plus 10, 19. Whew. I see one more. Let's put a D, an E, and an F. And you know, we're done. Because that is our last possibility. Anything else we try to put together here will have already been repeated. And remember the whole idea with a combination, it doesn't matter what order the letters are in, but once you pick those 3 letters to get grouped together, that's it. They're done. So it looks like we have 20 cranking it out. And I said there's a formula. I'm going to give you a little formula on that. To find combinations, we say 6 items, and those of you are in Algebra 2, Algebra 1, you've dealt with these things. They're part of your state tests and such. And those of you are taking statistics, you're using them quite a bit. So we're going to say 6 items taken 3 at a time. We also will call this our n, and we'll call this our x for lack of anything better. I always like variables, you know that. Now, what do we do with those variables? I'm going to put them up here in variable form. We're going to put an n with a factorial, which means 6 times 5 times 4 times 3 times 2 times 1. That's what a factorial is. It looks like an exclamation point. In math, we call it factorial. So n, it's not an exclamation point. It is just a factorial. Now, underneath there, we're going to take n minus x factorial, but we're also going to take x factorial. And you say, well, Ernie, what's x? X is 3, right? So here's our numbers. We're going to be looking at 6 factorial, and underneath, to divide by, we're going to say 3 factorial times 3 factorial. Now, 3 factorial is pretty easy. 3 times 2 times 1, you get 6. Do it again, 6 times 6. So in the denominator, we're looking at 36. The question is, what are we looking at in the numerator? My goodness, we're looking at something big, it looks like. Could it be 6 times 5? Well, let's see. 6 times 5 times 4 times 3 times 2. Let's see what we got. Let's go to the calculator on that one. And we've got 6 times 5. That's going to give us 30. All right. Let's multiply it times 4, which bumps us up to, 120. Multiply by 3. Now we're at 360. We're getting up there. Multiply that 360 times 2. I'm looking at 720. That's where we are. Now, you guys, we're taking that 720, we're going to divide it by 36. Back to the calculator one more time. And I'm hoping for 20. We're all hoping for 20. You got 20. There's the way you work it out by formula. Like I said, for those of you who are in Algebra 2 and statistics and those things, that's a lot of what you're doing. And then some of you say, we just got the calculator, there's a button on there. And that's true. But right now, problem of the day, we have solved it, cranking it out, using the combinations formula. And yep, there's even a button that'll take care of you on the old graphing calculator.